All right, today's talk is going to be on hearing, the sense of hearing. And the first thing I want to do is take just a quick physics lesson and compare the means of how the sound gets transferred to your ears. If I take a look and compare, first of all, the light. We went over light in the last one, and light has a frequency and it has a wavelength, and we perceive those different wavelengths as different colors. The light travels through outer space or through complete vacuums really, really well. It travels the speed of light. That doesn't happen with sound. Sound has to have a medium. It has to have gas. It has to have a solid. It has to have something. We can't hear sounds from outer space because it can't move in outer space. If I take a look at the air as I'm talking, I am compacting part of them together, and then part of them are getting further apart. So if I kind of compare it to a wavelength here, the sound I'm squishing it together, and then it's further apart, and then I'm squishing it together, and then it's farther apart, squishing it together, and then it's farther apart. So kind of the same thing, I have a wavelength that I can measure. And that wavelength is the compactions, where they're closer together, and the rarefactions, parts where they're further apart. So those frequencies, if that's what you want to call them, we perceive as pitches. So we perceive those as high and low. So something that is high in pitch, the wavelength is closer together, and if I go low, they're further apart. Okay, but I have to have a medium. It travels through air. Does it travel through water? Yes, better. I mean, whales can communicate from miles away. Does it travel through solids? Yes, even better. If you put your head down and you would hit the table, or put your head on the railroad track and hit it with a hammer a mile away, you'd be able to hear it. So it has to have a medium. So that's one of the main big difference on how the sound travels compared to how light travels. So if I take a look at a picture of a diagram of the ear here, and first of all, you should notice that we have an external ear, and then we have a middle ear and an inner ear. On the external ear, we have the pinna or auricle, your outer ear. The lobe is just a part of it. Helps funnel the sound to some degree. Then the sound, those compactions and rarefactions. If I just draw an arrow, we're going to come down my external auditory canal, and it will strike the tympanic membrane. Tympanic membrane is kind of in a way like a skin over a drum, and you hit the drum and it vibrates back and forth, and it makes sound. Well, this doesn't make sound, but this is going to vibrate back and forth at the pitch or frequency that the sound's hitting it. Then in the middle ear, I have what are called the ossicles. There's the ossicles. And the ossicles, here's your trivia contest winner. The three smallest bones in the body are found in the ossicles. They're called the malleus, the incus, and the stapes. In simple terms, they call them the mallet, an anvil, and a stirrup. They kind of resemble those structures. What is their job? Their job is to amplify the sound. So my tympanic membrane is going to vibrate back and forth at the frequency that the sound hits it. The malleus is attached to the tympanic membrane. So it is going to vibrate back and forth at the frequency that the tympanic membrane moves. It articulates or has a joint with the incus. So it was going to move the incus. it articulates with the stapes. So what happens, you have a big surface area here, the tympanic membrane, and you have a small surface area here for the end of the stapes, so it's going to amplify the sound. Really helps when it's soft. It's going to help amplify that so I can hear it. Now, you say, well, what happens when it's really loud? There's muscles that hook onto these bones, and they contract, and it doesn't amplify it. It tries to muffle that sound to some degree. Now, long sounds, loud noises for long periods of time aren't good, and it damages the eardrum, or it damages the nerves in the cochlea, actually. All right, so we've amplified the sound. So the sound now is has been transferred to the structure of my inner ear. This is where all of the actual receptors are found for sound. We don't hear anything. We don't perceive it in our middle ear. None of the receptors are found there. It is just amplifying the sound. Before we go on, I guess I do want to take a look at something that's different about the middle ear. This is gas-filled. We don't have a lot of gas-filled chambers in our body. The bad thing about gas-filled chambers in the body, as the atmospheric pressure changes, if you go up in elevation or down in elevation, or we got a cold front or a warm front moving in, the pressure changes fairly fast. That'll be a difference of pressure on the inside ear or on the middle ear compared to the outer ear. So in other words, this pressure pushing here and this pressure pushing here will be different. And we feel that and perceive that as pain. So we need to alleviate that somehow. And that's done with my auditory tube or a eustachian tube. There's a very small canal, and you see here it says it's going to the pharynx. So that's in the back of my throat. So when you pop your ears, you are equalizing the pressure in your middle ear compared to atmospheric pressure. And if you can't, that pressure builds up. Like if you get a cold, a lot of times, because this is a really small chamber right here, or a very small canal. If that gets plugged with mucus, you can't equalize the pressure inside and out, and then that builds. And a lot of times we have a hard time with pain, and it feels like pressure building up. It does it in our sinuses too, which are fluid filled. All right, so the sound now has transferred from the tympanic membrane to the malleus to the incus to the stapes to a structure here called the oval window. So that stapes is going to move in and out, and it's going to vibrate the vestibule, which is going to send that vibration down this cochlea. And it is a snail-like structure that is going to coil around. To make this kind of a long story short, inside of the cochlea there are fibers basically dangling down, and there is fluid in here. So as my stapes goes back and forth, it is going to move the fluid back and forth. That is going to move these dangling fibers back and forth. And certain frequencies, when it's at a certain frequency, this one will fire and send it to the brain. And another frequency, this one would fire and send that to the brain. When I take a look at it at the very beginning of it, so as I start in here, these are the high pitches. And basically as I get going in here and I keep going down and down and down, it keeps getting to lower and lower and lower. So the ones at the beginning that are dangling in here are going to be activated on high pitches. That's one of the main reasons why as you age, you can't hear the high pitches. Those are the ones that are most vulnerable. They're right away there. Okay. While we're in here and taking a look at the inner ear, let's also take a look at what are called the semicircular canals. What are they? They are 90-degree semicircular canals from each other. They're in 3 different planes. And we'll just say that it's very similar to what happens in the cochlea. And so as I have a canal, a semicircular canal here, in here I would have these, actually they're otoliths and they're a little bit different, but we'll just say that they're fibers hanging down. So if I would lean my head down this way, the fluid in here, the gel-like material would move in that direction. Gravity would pull it down. And therefore these fibers would move, and when they move enough, it sends that message to the brain. So what does that do? It tells me the orientation of my head. So if I move left to right, let's say this one, if I take a look at it, if I move left to right, it's this one. Oop, that didn't work out very good. As I move left to right, this one would be activated. If I moved straight forward, this one would be stimulated. So it tells me at all times which way my head is in proportion to gravity. So it lets me know where my head is at. It helps you with balance. So in a nutshell, that's those structures of the ear and the inner ear, middle ear, external ear. I guess I didn't mention the round window here. The round window is a structure that will everything here except for the oval window. All of this material in here is all solid bony material, except for the round window. So it allows to dissipate the pressure from the fluid in there. So it'd be really instrumental in really loud noises to try to so that it doesn't push too hard on it in there. If I take a look at some quick things here to finish up the hearing, cerumen, that's earwax. It helps supposedly, keep things out. It also helps muffle loud noises. If I take a look at hearing loss, a couple different ones I have. Conductive hearing loss, it just, could be something as easy as something's plugged in there or too much earwax. Sensorineural hearing loss, that's some nerve damage usually. An example and a symptom of that is tinnitus, the constant ringing of the ears. A lot of you probably have had the external otitis, or what we call swimmer's ear. A lot of times that happens when you get water on the ear and then you get bacteria or a fungus that gets an infection in there. Otis media is an infection of the middle ear. And so basically it's on the other side of the membrane. And a lot of times it's bacteria and fungus again. A lot of times you get those when you're an infant and if you're nursing all the time, the actual sounds kind of weird, but milk can get into this small opening, because remember, that's in the back of the throat. That's why they're not supposed to nurse and put them to sleep at the same time, because things relax and milk can get in here. And if you get fluid in here, you're going to get a lot of times a bacterial infection. So what do they do to that? And some of you might have had this when you're young, that laryngotomy, where they put a tube in the ear. What's a tube in the ear? So they will actually put a very, very small tube and put it in your tympanic membrane. And what will that do? It'll drain that fluid out just naturally. And I've seen those tubes. They're literally tiny plastic tubes. And what happens to them? They eventually just fall out, and then the tympanic membrane will heal. Okay, that's the end of our hearing talk. Hope everything's going well. Talk to you soon. Bye.